Hi friends, I'm sure you've all heard that light travels in a straight line. It's called the rectilinear propagation of light. But are you ready to try your magic trick with me where we are going to bend light? For the magic trick, I just need you to get a transparent glass like this filled with water. So pause the video here and go and get a glass of water. Are you ready with your glass of water? Next, I'll be showing an arrow on the screen and you pause the video when you see the arrow and hold up your glass of water in front of the screen, something like this, and look at the arrow again and tell me, what do you see this time? Did you see the magic? Did you see the arrow changing its direction? It's happening due to bending of light. This is called refraction of light and it's going to be the topic of this video. And then as usual, we'll finish off with our top 3 questions on this topic. I have this torch here with me. When I switch on the torch, it gives out a beam of light. A beam is composed of many rays of light. As you can see, each ray is traveling in a straight line. Now for simplicity, let's consider a single ray of light. Now how do I bend this ray of light? I can't just grab the ray of light and bend it, right? So what do you think I need to do to bend the light? You might be thinking of using a mirror. So a mirror certainly changes the angle by reflecting back the light. But what if I ask you, I want the light to continue downwards and still bend it? Then what do we need to do? So you need a transparent material like glass or plastic here. Let's imagine there's a large glass block kept here and I'm going to shine this torch on the glass block. Again, we'll consider a single ray of light for simplicity. Can you see the ray of light bending as it enters the glass block? This is known as refraction of light. There is also a partial reflection when the light hits the glass surface. But we'll ignore that for this video and our focus will only be on refraction of light. So what have we learned till now? Light travels in a straight line as long as it's traveling only in one material. So as we saw here, as long as it's traveling only in air, it's traveling in a straight line. And then if you look only at the glass part, light is traveling in a straight line. But when light travels from one material to another, so here from air to glass, it bends. And this bending of light is called refraction of light. So here's the fancy definition of refraction of light. Refraction of light is defined as the change in direction of light when it's traveling obliquely from one medium to another medium. So what does this all mean? Let's break it down here. So change in direction means bending of light. Obliquely means the light is incident at an angle. And the word medium means material. For example, air, glass, water, these are all materials. You may also see the term optical material because optical refers to light. And for refraction, remember that the material needs to be transparent. Let's place the definition of refraction of light on our concept board. Have you seen any simple everyday examples of refraction? One thing that you might have noticed, or you can try yourself, is take a pencil and put it in a glass of water. The pencil will appear bent. It's due to refraction of light. Another example is if you go and stand near a swimming pool, it actually appears shallower than it really is. And of course, the magic trick that we saw at the beginning of the video. So do go ahead and show it to your friends, but don't tell them the secret. And there are many other examples of refraction, but we'll look at those in detail in a separate video. Now that we know what is refraction, let's take a look why refraction happens. So what is the magic this glass block is doing to bend the light? The answer is it changes the speed of light. So let's say the speed of light in air is approximately 3 into 10 to the power 8 meter per second. And since glass is denser than air, it slows down the light when it enters the glass block. And let's say the speed here is 2 into 10 to the power 8 meter per second. So this change in speed of light when it's traveling from air to glass causes the light to bend. And greater the change in speed, greater will be the bending of light. We've seen what is refraction, why refraction takes place. Now let's take a look how light bends during refraction. In this case, we saw light bends this way. But is it possible for light to bend the other way also? Let's go ahead and take a closer look. Let's look at some terms first. This ray of light is called the incident ray. Do you know where is the point of incidence? That's right, it's here. The point where the incident ray hits the second medium is called the point of incidence. Now let's draw an imaginary line perpendicular to this boundary between the two materials. This perpendicular line is called the normal. The light ray in the second medium is called the refracted ray. Can you see the incident light, instead of going straight, is bending towards the normal? The angle the incident ray makes with the normal is called the angle of incidence. And the angle the refracted ray makes with the normal is called the angle of refraction. When light is traveling from air to glass, like here, how are these angles related? That's right, angle of incidence is greater than the angle of refraction. Here, air is the rarer medium, or to be more precise, optically rarer medium, and glass is the optically denser medium. We use the term optical density because it's different from normal density. Normal density is the heaviness or lightness of a material and is measured as mass by volume. But optical density measures how much a material is able to slow down light. And note that a material that is denser than another one need not be more optically denser than the other material. So this was our case 1. When light travels from a rarer to a denser medium, the speed of light decreases. The light bends towards the normal. And as you can see, angle of incidence is greater than the angle of refraction. Now, can we make the light bend away from the normal? The answer is yes. We just need to switch the two materials. So as you can see, this is our case 2. When light travels from a denser to a rarer medium, the speed of light increases. And as you can see, the light bends away from the normal. And the angle of incidence is less than the angle of refraction here. Let's pin these two cases of refraction on our concept board. There is another interesting case where the light is incident normally on the second medium. As you can see, the incident ray is along the normal here. But even though the light is traveling from air to glass, can you see that there's no bending taking place? So we say there is no refraction happening here. But does the speed of light change when it enters the glass block? The answer is yes. As expected, the light will slow down when it goes from air to glass. But in this interesting case, there is no bending of light happening here. What is the angle of incidence here? That's right, it's 0. The angle between the incident ray and the normal is 0. What is the angle of refraction in this case? Correct, it's 0. The angle between the refracted ray and the normal here is 0. Let's place this special case of normal incidence on our concept board. Now that we are done with the topic of refraction, are you ready for the top 3 questions on this topic coming up for you right now? Friends, try solving these questions and let me know your answers and doubts by putting it in the comments below. I promise to reply to all your comments as soon as possible. So I'm going to bend away like light and you pause the video here and give these questions a shot. As we discussed in this video, refraction is the bending of light when light travels from one medium to another. Refraction is caused by the change in speed of light. And do remember